In this video, we'll be looking at how to convert a biphasic compound action potential into a monophasic compound action potential. Now, in addition to simply performing the action, we do want you to understand why we might be interested in converting a biphasic compound action potential into a monophasic one. On page 5, there is a question about this. Question 2, why is a monophasic recording a better representation of overall nerve electrical activity? Now, because this is one of your questions, I'm not going to tell you the answer, of course, but have a think about what we've seen so far. We've had a look at action potentials travelling along the axons that form part of the sciatic nerve. We've seen that when we get an action potential passing over the first of the recording electrodes, we get an upwards deflection on the trace we see on the screen. Then, when the action potential passes over the second recording electrode, we get a deflection downwards in the opposite direction. We've also seen that a compound action potential is simply the summation of all the action potentials above a given recording electrode. Lastly, we've also seen that the sciatic nerve is a very large mixed nerve, meaning that it contains axons of lots of different fibre types. When we stimulate the nerve to activate those axons, we get hundreds, if not thousands, of action potentials being generated at once. Now, because there's a range of different conduction velocities, those action potentials will make their way down the nerve at different rates. Action potentials with the fastest conduction velocity will reach the recording electrodes first, followed by fibres with an intermediate conduction velocity, and action potentials in fibres with the slowest conduction velocity will reach the recording electrodes last. Now, because of this distribution in conduction velocities, some action potentials are going to be arriving at the second recording electrode, while other action potentials are still arriving at the first recording electrode. So your job in answering this question is to have a think about what effect that's going to have on the trace that we're seeing displayed on the screen. Okay, now to perform the conversion, we're going to just follow the methods on the screen as we did for the first activity. And so first of all, we just have a reminder to keep the nerve wet. So we'll take a small bit of saline and just make sure that there's enough liquid over the nerve to keep it moist and alive. And then instruction 2 says to actually perform the nerve crush, but we might just get a response on the screen first. So let's go to instruction 3, set the stimulus voltage in the stimulator panel to 1 volt. So if we scroll down, we can see that ours is already set at 1 volt since that's what we were using before. So let's get a response on the screen and we'll click start. And so this is our biphasic compound action potential. Now, this particular nerve doesn't have a very pronounced second phase, so the downward deflection isn't very noticeable. I think in the example data that we've given you, the nerve that we used for that particular data has a very pronounced second phase, just so you can see some of the biological variation that you have between nerves. But either way, we'll still perform the activity on this particular nerve as well. So if we come out here to our nerve, we've got the nerve sitting on top of the electrodes of the tissue bath, and down the right-hand side we've got our 2 recording electrodes. Now, to prevent action potentials from travelling between the first and the second recording electrodes, what we're going to do is crush the nerve between those 2 recording electrodes. So that way the action potentials can only travel to the first recording electrode, but because the nerve's crushed, then they can't travel any further along the nerve, so they can never reach that second recording electrode. Now, to perform the crush, we just take our forceps and squeeze the nerve between the first and the second recording electrodes. Now, the nerve's a little bit sticky, so I'm just using my scissors here to sort of try to keep the nerve down to prevent me from dragging it off the top of the wires. And so once your nerve's settled in place, we've got the crush between those 2 recording electrodes. So let's go back to our computer screen and we'll click start. Now notice how there's no response on the screen. So because we've crushed the nerve, typically the nerve will be quite disrupted, and so the baseline won't necessarily be at the same level as it was before. Now, if you ever can't see a trace on the screen, remember we said to click the auto scale button, and that will just scale everything, particularly in the vertical axis, and bring everything onto the screen so we can see the response. We can also use the manual scale buttons just to make the response a little bit bigger, and so there's our response. Now, the peak of the response is still occurring at the same time after the stimulus artifact, but I'll leave you to describe what you think happened to the compound action potential after we performed the nerve crush. Let me put a picture of the biphasic compound action potential that we had before here, and the monophasic action potential that we achieved after the crush here. So have a look at the two and see what you think the differences are. Once you've done that, head over to page 5 and work through the series of review questions on the monophasic action potential.